could put that on there. And you could put it on immediately. Like we have the stir bar in there, and generally you add your solvent into this reaction. Let's say a solvent is ethyl acetate. For solvents, normally, unless it's specified, you could use a measuring cylinder, right? We have different types of measuring cylinder, different sizes, glass, plastic. These plastics are made so that they could be resistant to organic solvents. So for the solvent, you don't have to be totally precise. If it says 25 and you got in 24, that's okay. You can put it into your actual procedure section. So here's the solvent. And normally we add in the solvent first before we start adding the reactants. And your procedure basically tells you to do that anyway. So there's a solvent. Use this. Let's say we're doing some reaction. This is a dye, liquid malachite green. And we want to put that in here. What do we need to do to weigh it out? What's the obvious answer?
The scale.
The balance, right? So here's the balance. I think there's one over there. Oftentimes you may not see weighing paper. If you don't have weighing paper, don't get all flustered. All you have to do, we have sheets of paper, lots of them that are considered scrap, is you get them, and you could probably make 8 pieces of weighing paper with this. So it's not a big deal. Don't come running to me, oh, I don't have any weighing paper. You just need to say, can I get some scrap paper? I'll make my own weighing paper. Okay? This is not a big deal.
What a man.
So, and if you don't have anything to do, which is not going to ever happen in this lab, you could always spend time making weighing paper for the rest of the class. Anyway, this is weighing paper, could be made from this, sheets. What I would suggest, and this is going to be, is anybody using lithium hydride by chance? Lithium hydride?
No.
Okay, that's a good thing. Did you use lithium hydride?
No, I use calcium hydride.
Calcium hydride. All right, I know everybody thinks they know how to do this, which you probably do, but you put your weighing paper in, you tar it, so now it's 0. Okay? And what I would suggest doing is, instead of doing something like this, right, and then putting it all the way through here, what I would suggest doing is to actually have this as close as possible, even inside, okay? And that would minimize spills and all of that. And so something like that is what I would prefer you do. This area is fairly clean. We want to keep it that way. The balance here is fairly clean. We have these brushes, and we have other hand brooms and stuff. I don't know if that balance over there looks clean, and the area not too good. I see stuff on the right hand side. So this is all part of being professional in the lab, is making sure when you finish using it, you clean it up for the next person coming along. So we take our product and we could do two things here. One is we could turn this into like a funnel, like so, and put it in. Or we could take an actual funnel, right? And remove this and put your stuff in. At first, I would probably suggest you guys using the funnel. Part of the reason is you try to avoid the reagents coming on the side of the mouth here, because if it gets stuck there, then you have less reagent to react, number one. Number two, when it stays here, it could start clogging up. For example, this wouldn't fit as neat and nice. When we are doing a reflux, and I'll show you with a condenser here pretty soon, that could really mess up the condenser as well. So if you happen to spill, especially solid stuff, on the inside of the mouth of the round bottom, you try with a glass rod, a spatula, or something to get it down. But first of all, try not to have it there. So you could use it this way. Okay. All right, so we have our reactant in there, and this is going to do either like a cold bath, low temperature, ice bath reaction, or if it's a room temperature reaction, you just have it here like so. Now, if we were going to heat this up to do a reflux, here's what you need to do. You need to use a condenser. And we have different sizes again of condensers. We have this, they all, let me show you, they all are made so that they actually, no matter what size, they all fit in here, from the big one here to the smallest one, they all fit, okay? So normally if you do a reaction, you don't want to use this big one. We mostly use these sizes like this and this one. So looks, oh, okay, yes, that's fine. Those are the condensers. Did you guys read up on the condensers and what they're used for?
They cool down the evaporation.
You guys got jokes, man. All right, so for a condenser, you have to use rubber tubing. There are different types of rubber tubing. This is more flexible. It could collapse very easily. Here's this one. This is what you use for the condensers. These Tigron, amber looking tubing. This is what we refer to as a thick wall tubing. And so those we would use when we're doing vacuum, but for putting, using water and setting up your condenser, these are what you use. I don't have a water flow here, a tap on here, so I'm gonna have to show you this next one in a hood. So we put, anybody knows where the water is gonna come from?
The bottom.
Yep, it flows into the bottom and out the top. And once you guys get comfortable, some of you are going to set up series of reactions where water coming from the tap is coming here. This top one could then go into the bottom of another condenser and flow out into another one. It could be like a series. Before you start putting flowing water through a condenser, because we don't know if it's broken or chipped or something that may allow water to start to seep out, we need to test it. Notice in these condensers, you guys can pass these around, there is like an inner tube and an outer tube. So the water is going to flow inside between those two tubes. Okay? You guys can take a look. So we go back here to show you how, because you'll be setting up in the hood. Okay? But before you put the condenser onto the round bottom flask, let's turn the light on. We connect, this is the water taps here. So there it is, it's connected. Now we're gonna have the water flowing here, cold water. And let's just show you the rate. You don't want this rushing through. This is too high of a rate. What you want is a little less. Something like this is probably good, or even less, okay, of a flow. Then you could see there is no leak in here. And at that point, when you're satisfied that there is no leak, then you could put it on top of the round bottom flask. Yeah, because some of your reactions definitely don't like water. Water in them is gonna just mess it up and you'll have to begin all over again. So let's bring this out. Okay, so just imagine that this is hooked up to your water. These are not water in here. So just imagine they're hooked up to the water. This one is flowing out into the sink. And so at this point you will start heating the reaction. Is everybody paying attention? You guys? You need to be paying attention. You may even want to come closer. You start heating this. When you're doing a reflux, you always turn up the heat. I would say most of these go up to like 500. Turn it up to at least 400. Okay, turn it up high. Don't turn it up to like 100 and then slowly go up. That's wasting time. You basically turn it up high to at least 400, 450. And what will happen is the liquid in here, the solvent, it becomes hot. It's going to start to evaporate. The vapors are going to start moving up. They're going to hit a cold surface. This cold surface, that inner tube, there is a cold surface now because of the water flowing. It hits that cold surface, it will condense. So evaporation and condensation will take place. It condenses, and then it starts dripping. The tip here, you're going to start seeing drips. That's not water, that's actually a solvent that has evaporated, condensed, and dripping back in. The first 2 or 3 drops, that's when you start counting the time. So if the reaction says 3 hours reflux, 3 hours reflux doesn't begin when you turn this to 400. 3 hours begins at the first 2 or 3 drops from the tip of the condenser. Okay? So one of the things you guys are going to all have to do is, and I didn't bring stickies here, but you know what they look like, is get a sticky, write your name, your telephone number, the start time and the end time for your reflux or for your reaction. If there are steps in between that you cannot get to, and I have to go take a look at it and do it for you, you need to put those steps there. It has to be clear for me. In fact, it might be also an advantage to actually leave your lab notebook. Okay, so I can actually see what steps are involved. So this, I don't want to really start this heating. Here, it doesn't have water flowing. This is how we set up our reflux. Okay? So everybody, guys in the back, you need to come closer. If you're not seeing, yeah, you need to come closer. Okay? A lot of you are going to be doing this. So let's assume that I think a couple of other things. So you saw how I weighed stuff on the balance, but in some cases you're going to use your reactants or liquids, and for those, except for the solvent, unless I tell you to syringe it, for the solvent you mostly use measuring cylinders. For reactants that are liquids, what you would be using are syringes. And we have big syringes, and we have small syringes. Okay? We have really tiny syringes, like this one hasn't even been opened yet, and it could pull up 100 micro, yeah, that's a microliter. It's really tiny amounts. So some of the syringes are glass, as you can see here, and some are plastic. The ones that we probably will use the most are these. These are 1 milliliter syringes, and what we would need to do is get needles. And these needles will be available to you on like the back shelf, usually, of the lab. We have back shelf there, and over in the other lab as well. So you open up this, and you attach your needle to the syringe like this, and then you could use it. Okay? You will notice this goes up to 1 milliliter, and you could get, so you could see 0.1, 0.9, 0.8, and so on. You could get 0.55. Okay? They have demarcations for those. But beyond the second decimal, you're not going to get on these. Okay? So, let's pull up some liquid. Let's try ethyl acetate. Okay? If you notice, you will see bubbles in there. That often happens. That's not like uncommon at all. So if you pull up a reagent and you see bubbles in there, what you want to do is do like this, and then this, or we may have some brown paper towels around, is try to get those bubbles out. Okay? And get it to the right amount that you want. Okay, so some of the reagents, reactants are going to be liquids, and in many cases you may have to use this type of syringe. Of course, again, if you have to use a bigger type syringe, that's fine. In most cases, once you finish with this syringe, you don't really need to use it again. There might be cases where